month. I'm retired, so all the days kind of run together. I think it was about a year ago at this time that I wrote an article about, there was a teaser that was entitled, "Are You Using Features?" And basically it was a promotion to encourage developers to use feature-based development. So maybe that could be a New Year's resolution. I'm not sure. I'll leave that up to you, I guess. Certainly, I am excited to talk about features, and I'm hoping to relay that excitement to you as well. So I guess before we get started, I'll give you just a little of my background. I'm a father and a grandfather. My wife and I have a son and a daughter and 4 grandchildren. So you can imagine we enjoy traveling and playing with grandkids. I also cycle just a bit, and I very much enjoy college football. I think we had a pretty good season this last year, too. Well, you can see here that I have been involved in software for over 40 years. My wife and I began our careers together. She also has a computer science degree. And we started our work at General Motors, and that was both a small town in Indiana called Kokomo, Indiana, and then eventually we got transferred to Detroit. So in the mid-'80s, we started our family, moved to the St. Louis area, and I started work for McDonnell Douglas Aerospace Company, now the Boeing Company. In the mid-'90s, I actually started consulting, and so I worked for a number of companies in the St. Louis area. And I actually retired in 2015, and that's when I started working in and contributing to open source. So there's one common theme on this slide if you haven't yet noticed, and that is I'm probably the old guy in the room, so you're going to have to cut me some slack. This is what computers looked like when I first. I'm a current developer from a different era. But and I do try to stay current as much as possible, but I think we can all agree that's getting harder and harder to do as technology is advancing at the rate that it is. Okay, so we're here to talk about feature-based development that plugs and plays. That was the inspiration for the Playful Features title. And specifically, we're going to be talking about a utility library called FeatureU, which facilitates feature-based development in the React platform. So I have to ask, how many React developers do we have? 2, 3, 2.5? I should mention that even though this is a React utility, that the dependency on React is really pretty minimal. I can see where in the future release we remove that dependency and open it up just a little bit. Certainly, the concepts that we're going to be talking about are applicable to any framework, to any language for that matter. So the main focus of FeatureU is feature-based development. It just happens to be React is what I implemented it in. Okay, before we get started, let's take a quick peek at the resources link that you see there on the lower right, or lower left. I've also listed that in my demo page as well on the upper right. If you missed it, it's a bit.ly link. It's feature-u-pres, P-R-E-S. And this is basically a link into my homepage. And if you click on the presentation syllabus, you can get down and look at all the different resources here. There's a number of resources. There's the teaser article that I mentioned at the very beginning, basic concepts, so the repo for the source code, some plugin extension points. The items that we're going to be focused on this evening is highlighted in yellow. So there's a copy of the slides there if you want to follow along. There's a link to the documentation. And probably the most important link is the third yellow highlight. Eatery Nod is actually a web app that's written using FeatureU. So we're going to be looking at that when we look at some code snippets a little bit later. While we're here, let's go ahead and take a quick peek at the documentation. FeatureU is really well documented, I think. There's a number of sections and chapters that build concepts and show you code snippets, and so you can look through that. Of course, I guess the mainstay of any documentation is the API, and this is all the functions that make up the FeatureU. So it's really a pretty small set of functions. If you click in there, obviously you'll see a detailed description of the function with its parameters and return types. But you're also going to find linkages back into the user guide that are context specific to that particular function. So it'll help you and look at some code examples there. Feature U is extendable, and there's an entire section on extending feature U. Typically, you're not going to get involved with that because hopefully you're going to be able to find the plugin already prepackaged in NPM. But if you can't find that and you need to write an extension, it's available there for your use. Okay. Let's go ahead and get started. We've already talked about the documentation. So I don't know about you, but the first thing that comes to my mind when I think about feature-based development is your project directory structure. So as a general rule, you have a very broad choice. You can organize your code by what it is, and that would be a type organization, or you can organize it by what it accomplishes, and that would be a feature-based directory structure. So basically on the type structure, you're going to organize your code based on some type classifications. So it's not uncommon to find code in directories that you'll find all your components in a directory, all your routes, and if you're modeling business logic separately, you might have a directory for that, as well as state management. So on the feature-based side, you're organizing your code based on features. And we'd like those features to actually follow your requirements. So that's what really makes it intuitive. So within one of these features, you're going to find all the components that make up that particular feature, regardless of its type, okay? So basically, all projects have features, right? The real question is, are your features is the code that implements a particular feature all nicely located in one spot? Or is it spread out across your entire code base as it would be in a type-based organization? Make sense? So also in a type organization, it's fairly common to find a directory where you'll find all the code related to the bootstrap startup of your application. When it comes to feature-based stuff, we like to encapsulate the startup initialization within the feature that actually requires that particular initialization. Now, that's going to be a little harder to do without some help. So we'll talk about that in just a moment. So I'm curious, I know this kind of represents extremes of two sides, but we are currently in your existing projects using something that might resemble the feature-based side versus the type-based side.
Almost always type.
Yeah? Okay.
But mostly because I haven't even thought about doing it.
Right, right. Well, I mean, I think the general consensus is that a feature-based development scales much better simply because there is that direct correlation between your requirements and the code that implements that requirements. And especially when you start getting into a larger enterprise scale application, you can see where if you've got hundreds or thousands of features, that it's going to be really hard to find where you're going to find code scattered all across your code base. So for that reason alone, I think it scales much better. So at this point, we're talking about how we organize our code, just the directory structures, right? Well, that's a good starting point, but there's a lot of things that we would like to accomplish over and above this directory structure. So we would like, I mentioned this before, we'd like our requirements based, and that's what really makes code base intuitive. Now that could be end user requirements, or it could also be lower level system level requirements. There's a lot of ways that you can organize your features, just like general design. So that's a big topic in itself. And that's really a design constraint. So it's really up to you to make that happen per se. We'd also like our features to be encapsulated and isolated as much as possible. We'd also, again, as much as possible, like them to be self-sufficient and self-reliant. And if we do this right, the feature is actually going to plug and play. Now, what I mean by that is the existence of a particular feature automatically, dynamically exude the characteristic that that feature implements. Well, there are a number of hurdles that we need to overcome in order to accomplish these goals. So as an example, how do you correlate the fact that we want our features to be isolated, and yet we know that a feature has to coordinate with other features within the system in some fashion? I've mentioned this before. We'd like our features to be, we'd like the startup initialization for each feature to be encapsulated within that feature. Welcome. Oh, that's all right. Another hurdle is framework configuration. Now that we've organized in features, it's difficult to configure our frameworks because we have to pull aspects out of all these features, whereas where they're in a type-based structure, typically a framework is kind of related to that particular type. Let's say state management, that's where you're going to find all of your Redux configuration, that type of thing. Also, UI composition. It's for components to cross feature boundaries. So how and allow that composition to happen across feature boundaries. Feature enablement is something we'd like to disable a feature even though it's part of our code base for a variety of different reasons. Maybe it's a license upgrade or something where it's available for some users and not other users, as a typical example. So in short, how do you achieve a running application from these isolated set of features? That's the question that is before us. We need to address in order to achieve our goals. And those two items are, number one, feature runtime consolidation, and number two, feature collaboration. Now, these are my terms, but it's pretty much what makes the feature use system work, so it's pretty important to understand. So let's take a closer look at each one of these. So the first one is feature runtime consolidation. This is really dealing with the bootstrap startup of your application. And we can really divide that into two sub-tenets or two subcategories. So the first one is app-specific initialization. And this is more related to the features themselves. Maybe one feature needs a database connection before it can be operable, right? Maybe another feature needs to do some other initialization, and maybe it needs to inject some DOM into the static root of your project's DOM. There's a variety of different things that could be requirements in that area. So the second subtenet is related to framework configuration. So this is more of a global process that's not specific to any one feature, because if we're configuring a framework, we're pulling aspects from all of the feature related to that, let's say state management, if we're doing Redux configuration. And so the question is, how do we manage that now that we've segregated all of our code into separate features? It's potentially a little more difficult. So the second major tenet that I mentioned is feature collaboration. And basically, we've already said that we'd like for our features to be isolated, and yet we know that a feature exists as part of an overall larger application. So as a result, we know it's going to have to collaborate with other features in some fashion, right? Well, you may be thinking to yourself, that's not an issue. I can simply import those resources that I need across the feature boundaries. And that's something that is tempting to do because it's really just a directory import away, right? Because all your features are typically packaged, right there together with one another. But as a general rule, I would consider this an anti-pattern. I don't really think that your imports should cross feature boundaries, simply because we want this to be a more formal process that is extendable. Let's just take an example. Let's say F1 resource from F2. Well, that's going to work initially, But if you think about it, with all the things we've talked about, that doesn't take into consideration some very basic characteristics of the feature, such as, is the F2 feature even enabled? If it's disabled, that resource is really not available to you, right? So that's one big example that we can talk about. There's several others that we'll see throughout the presentation here. But in general, if we throw out this concept of cross-feature import, the question remains, how can we achieve cross-feature communication in a way that doesn't break encapsulation? Make sense? All right, well, these items form the basis of why Feature U was created. When it comes to this topic, there's a lot of good articles out there, but in terms of the implementation, you're pretty much left to fend for yourself. So that's why I started thinking in terms of a library to see how it could facilitate this process. So here's the ultimate goal of what we're trying to accomplish. If we can organize our code into separate isolated features that are requirements-based, and if we can encapsulate the initialization within the feature that requires that particular initialization, and if we can provide a mechanism by which a feature can be disabled at runtime for, again, a variety of different reasons, and most importantly, if we can define this characteristic to where features can collaborate with one another in an extendable way, then we can achieve our ultimate goal of plug and play, where the mere existence of that feature exudes the characteristics that it implements dynamically and automatically. So if you think about it, what we've really done is we've broken our application up into a series of miniature applications. And basically each feature then is providing, it's self-reliant and encapsulated. It's loosely coupled so that it improves modularity. And in general, it just makes our system easier to understand, to develop, to test, and to refactor. So this is actually very similar to how microservices work, if you've delved into that at all on the server side. And so it's kind of a similar goal. You've probably seen some articles. It's sort of, I think, becoming popular now, called micro front ends, right? I really think that when you apply this feature-based development to the front end, it is definitely within the category of micro front ends. So at first glance here, that may seem sort of overwhelming, but it's really not if you approach it in the right way. We're going to be able to see all this in action with Feature U, and it's really not that hard, again, if you approach it the right way. Okay, we're going to be looking at quite a bit in this presentation. We'll be looking at how your app startup process can be simplified. We'll look at feature enablement and disablement. We'll spend quite a bit of time with cross-feature collaboration. And we'll talk briefly about A/B feature swap, something that's very common in a feature-based development. But all these items we're going to be looking at from the perspective of how we can achieve our ultimate goal of plug and play. We'll be talking about that quite a bit. So to make sense of this, we're going to be looking at a real application that's implemented using Feature U. Eatery Nod is a web app that basically does a random selection of a restaurant from a pool of favorites, okay? My wife and I have a steady date night with another couple, and we're always indecisive about which of our favorite restaurants we want to frequent. And so Eatery Nod provides the spinning wheel. So in other words, it gives a nod to an eatery. My wife and friends aren't really enamored with the name, but I tell them that geeks have to have fun somehow, and naming stuff is pretty much one way that can happen. So let's go ahead and take a look at the actual app here. This is the Eatery Nod app, and it does require an authentication. And this authentication is actually backed by the Firebase cloud service, if you're familiar with that. So once you've signed in, your ID is given, is assigned a pool of restaurants that you can maintain persistently. And again, that is actually backed by the Firebase real-time database. So this is, you can see I've logged in here. I've actually named my pool date night. And so here's all of our favorite restaurants. So the main function of Eatery Nod is the spin button on the bottom. So if I spin, you can see I'm spinning over 65 entries. And here is our restaurant for this particular Friday night, date night. If you don't like that, you can actually cheat and spin again. You can do things like, let's say you want to filter this. Let's say that on the pool, you're tired, you don't want to travel very far, so limited to 3 miles and sort it by distance. And so on a much smaller list here, if I spin, it's spinning against 22 entries instead of the original 64. So within the detail screen here, you can actually interact with these entries directly. So I can do direct navigation, I can phone the restaurant, I can bring up their website if I want to look at the menu, etc. Well, how do you maintain this information? There's a lot of detail for each restaurant. It would be pretty tedious if you do that by hand. And fortunately, there is a second view called the Discovery View. That does a geographical search of restaurants in close proximity of the device. Now this is actually backed by Google Places API. So it's very similar to doing a Google search. We're getting it right. The main difference is we keep track of whether or not that restaurant is in your persistent pool of favorites, and it'll have a red checkbox by it if it is, okay? So that's actually a toggle. All I have to do to add a restaurant is toggle that. It turned red. If I go back to our pool of favorites, you'll see that Jimmy John's is now in my pool. So all that information was entered from Google Places API. So there's quite a bit of features in this system that are considered common features that are implemented in an app-neutral way. This left nav menu is that way, the title bar is that way, pretty much all the user menu is that way. The description along with some documentation and history links. And this particular information is pulled from your package.json file. That's how it can be implemented in an app-neutral. So what I mean by that is those common features are app-neutral. So I could pull those features out and plug them into an application and it would start working immediately as if. The system is use the real estate points where you want response breakpoints to occur. As an example, if I'm looking at the detailed screen, if I'm on, let's say, a cell phone, it's going to take up the full available on the cell phone. But if I'm in a little larger amount of real estate, that, and in fact, so that it goes into, from a simple list into a table. And there I can actually interact with all those without going in. Tired of all the to-do apps that you see in presentations, right? I tried to write the app in such a way that it was really production quality that you would see in an enterprise level system. So let's go ahead and take a look at just a quick look at some of the source here. So from the resources, click on the Eatery Nod link that goes into the GitHub repo for this. And Eatery Nod is actually fairly well documented. You'll find README files scattered throughout the project. And so what we're interested in here is I want to go into the source tree, and pretty much all of the features are found in the features directory. There's also a README file there that basically gives you a short description of each one of the features that make up the application. So I think with the brief intro that we've had, you can already recognize some of the features. Here's an eateries feature and a discovery feature, and then a whole series of these common features that I was talking about that are implemented in an app-neutral way. There's a base UI that provides the UI foundation for the system. Here's an authorization that's going to interact with Firebase to do the authentication. Here's a location feature that's actually going to maintain the GPS location in our application state. Diagnostic, there's a couple of diagnostics, et cetera, et cetera. You'll notice here that there's also some sub-features within this. So I've encapsulated the services for eatery, has an eatery services, there's a discovery services, and down in the authorization, there's also an authorization service as well. We're going to be talking about each one of these in a little more detail in just a moment. Go ahead and click on the eatery features. Again, you're going to find README files scattered throughout here. So here within the eateries features directory, you'll find screen flows and state transition diagrams for documentation. If I back up out of the README file into the eatery, so here are all the components that make up the eateries feature. Now, one of the things I want to look at here is all the features promote a feature object from a feature U perspective, and that's in the feature.js. So you can see here where it's calling create feature, that's a feature U function. Basically, the features are simply a lightweight catalog of aspects that are of interest to feature U. So we're going to be talking about this in a little more detail, but here you can see it has a name, for example, and then it's registering several things here, and we'll talk about this in more detail. The key takeaway from this is every one of the features within the feature directory is promoting this feature object, which a feature U is going to consume, as we will see in just a moment. All right, well, that's eatery nod in the nutshell. What I'd like to do is take a sneak peek at a that we can do using feature U, and this is more just to kind of wet your whistle to get spark your interest a little bit to see what we can do with the utility before we get into some of the details. The first one here is basically dealing with the application startup process. So all developers complain about the amount of boilerplate code that's necessary to start up your application up and running. I don't know if you've ever played this game with any of your colleagues. I can write that function in X lines of code. I put a pretty high number there. If you're dealing with a real enterprise level application, the amount of code that is involved in your application startup can really add up. So what if I told you that I can start your application with a single line of executable code? And that was true regardless of how complex your application was, and that it included both app-specific initialization and framework configuration. Well, I can hear the murmuring now. You guys are saying, this guy's gone over to the dark side of the marketing department and is really blowing smoke. And I guess I may be exaggerating just a little bit, as we will see, but there really is a single line of executable code that starts your application up and running. So let's take a look at that. So I'm going to bring up the actual source in my editor. So here I am in the source tree of eatery nod. If I expand the source, basically at the root of the source, there's an app.js file. And as I promised, there is a single line of executable code. I'm invoking a feature U function called launch app, and I'm basically passing it some features and a couple of callback functions, and I'm done. The application is up and running. Well, by way of a hint of what's going on here, we actually have successfully encapsulated our startup initialization within the features itself. And so given the set of all the feature objects that make up the application, which is the primary input to launch app is actually able to interact with those set of features and do the appropriate startup initialization. Okay? So you are going to find a little more of that code elsewhere. But as we will see, some aspects of your startup initialization is completely removed outside of your code base, and that is the framework configuration. We'll be talking about that in just a moment. So at any rate, that's the teaser. We'll come back to that once we learn a few more constructs with feature U. The second thing I would like to show you is really plug and play. And again, this is where the mere existence of a feature exudes the characteristics dynamically that it implements. And this can be either physical or logical. We can actually, at runtime, disable a feature, and all the aspects that it's implementing are dynamically removed. So let's look at that in action. Oops, got ahead of myself here. So let's say that in our application, we've decided that we want to make the discovery view optional, or I should say it's only available to licensed users. So if you're a paid subscriber, we're going to give you the discovery view. You can maintain your restaurants very easily. If you're just a guest user without paying anything, then we're going to force you to manually enter all that information by hand, okay? Well, that can actually be done very easily. If I expand my features and go into the discovery feature, let's bring up its feature object. And so here's the discovery feature. There is actually an enabled property. And if I resolve that to a false, it's basically going to be logically removed. Now, normally you wouldn't hard code this to false because you want it to change at runtime. So this normally would be a runtime expression of some sort. But since I haven't architected that in the system yet, I'm just going to turn it off to show you what will happen here. So if I save that, the system will rebuild. And if I look at the left nav menu, lo and behold, there is no discovery view. It's gone. Now, I should mention that there is no conditional logic within my application that's making that happen. It's merely the fact that the feature was removed. That's what I mean by plug and play, the dynamics of plug and play. All right? Make sense? So again, this is just a teaser. We're going to be looking at how that actually is accomplished shortly. Get that back to the normal. Make sense? Okay, the last sneak peek I'd like to show you is the A/B feature swap. This is something that is very common in feature-based development where you want to swap out one feature with another, and there's a variety of things that we can talk about that. We're going to be focused on this teaser with mock services. So I want to be able to swap out my real services with mock services. And using feature U, we can do that by promoting these services through features, through the collaboration that we mentioned briefly. So basically, if you look at the source code, again, at the root source, right next to the app.js, there is a features flags module. And there's a number of flags on the features there. This is just a configuration for this particular application. One of them is use Wi-Fi. And so you can see there in the comment that it says it's mock services. Have switched over to. So the system rebuilt, and you can see that I've logged in now as the mock guy, and my pool is called mock, and all of a sudden all my restaurants are from New Orleans, if you notice. And that's basically a representation of my mock service. It's basically a hard-coded in-memory database in my mock that's doing that, right? Well, obviously, I haven't shown you much about. Again, we're going to get into that once we learn some constructs from feature U of how that's happening. So again, I'm going to turn that back to normal before we continue and go back. Okay. So hopefully I've piqued your interest on that. And so I'm anxious to start talking about some characteristics of feature U. Any questions before we continue? Yes? I've been asked that question before. I can't imagine any performance issues here at all. It's really related to how the code is orchestrated. So yeah, I would say no, there's none. Well, I mean, ultimately, that's interacting with initialization for features, and it really depends on how intense. I mean, feature U is not adding any performance characteristics. If there was something in your initialization that was performant related, it's going to be the same thing with or without feature U. All right, let's start talking about some characteristics of feature U. We've already seen that launch app is a very key component of feature U. Basically, is a function that's working as your agent on your behalf, so to speak. Again, it's orchestrating this initialization process for you. And it does that with a very minimal amount of input. The primary input we saw to launch app is the set of feature objects that are promoted by each one of the features. And again, the feature object is merely a lightweight catalog of aspects that are of interest to feature U in starting your application up and running. So let's take a closer look at one of these features relative to the feature object. So as a general rule, within your feature, you're going to have, again, a number of components and aspects that combine together to implement that particular feature. Now, as a general rule, these items are considered to be a private implementation detail. Again, we want to encapsulate our features, right? But some of these items are of interest in starting up your application, and that's where the feature object comes into play. Now, you'll notice here that I've color-coded some of the properties of the feature object. The red items are built in, so they're available core feature U out of the box. And the green ones are extension points. So we've pulled in some additional NPM package extension, or we've developed our own extension, as I mentioned earlier. But in general, you can see that every feature has a name that's unique. It can be enabled or disabled. Facets is feature assets. We're going to be talking about this a lot more in just a moment, but basically that's the public API of your feature. It's how this cross-feature communication is going to happen. The reducer, it looks like, is this feature must be doing some state management, so it's registering its reducer, which would be, if you're familiar with Redux, it's going to be basically a feature-based slice of state of the overall application itself in state management. It also looks like this module where we must be using some logic package utility to manage our business logic, as an example. So it's registering something there for a framework. This last one is app will start. It looks like it's some kind of an application lifecycle hook for initialization, maybe. Well, we're obviously going to be talking about this in more detail in just a moment. But the takeaway from this is the feature object, again, is merely a lightweight catalog of aspects that are of interest in starting your application up and running. Make sense?
I've never seen the word facets spelled that way. Is it an acronym?
Yeah, it's an acronym for feature assets, okay? So yeah, it's pronounced facet, and it's kind of loosely related to that term, F-A-C-E-T, but it is a feature asset. Yeah. All right, let's look at some, drill in a little more specifics of what feature U is doing here. Remember the first major tenet that I talked about was feature runtime consolidation, and we broke that down into app initialization and framework configuration. Let's see how feature U accommodates each one of these two sub-goals of runtime consolidation. So from what we know about launch app so far, we know that it's in control of starting your application, given all the features that drive it, basically. So if you think about it, it's in a very prime spot to introduce application lifecycle hooks. So these are merely callbacks into the feature to do whatever initialization that feature deems fit. Okay, so it's just really orchestrating the control of this. So you're going to find initialization code within your features to do the appropriate thing. There's 3 of these application lifecycle hooks, and I've color-coded them so you can find them easier in the diagram. The first one is app will start, and I've color-coded that one yellow. And so that one's invoked very early in the app startup process. And basically, you can do any kind of initialization you want in the hook. But the hallmark of this one is that it supports accumulation of the static root DOM. So if this function does a whole bunch of initialization, but in addition it says, I need to inject something into the root, the static root DOM, it simply returns it. And that's accumulated by feature U for you. So you can see here that the F2 feature has a yellow app will start, and the F3 feature has a yellow app will start. So very early in the process, launch app is going to call out into F2 and F3 to do that specific initialization. The second one is app init, and I've color-coded that one in blue. And that one's invoked later in the app startup process. And again, just like app will start, you can really do any kind of initialization you want here. But the key hallmark of this one is it supports blocking asynchronous initialization. So if you return a promise from this function, then feature U is going to block until that function completes successfully. So presumably that asynchronous process needs to complete before that particular feature is considered operable, okay? So feature U is going to manage that for you and block for you. It actually blocks, it actually kicks off all the app inits in parallel and then blocks for each one to complete. So you can see here that the F1 feature has a blue app init registered, the F2 feature has a blue app init, and so later in the process, launch app is going to call out to F1 and F2 to do that initialization. The third and last callback is the app did start. And this one is actually invoked immediately after the app is up and running. So it would be used to trigger some kind of a process that basically requires the entire application to be up and running. The example I use in eDRE-Nod is your authentication. Your authentication needs to kick off at the very beginning of your process, but it needs the app to be up and running because it may need to actually gather information in a dialog box from a user, right? So this would be a trigger for it to kick off. And so in essence, that one's green. I've only got one registered. The F3 has an app did start. So very much at the end of launch app's life cycle, it's going to call out to the F3 feature to do its app did start. And then pretty much it's done. Your app is up and running at that point in time. Does that make sense?
Are there life cycle hooks for if like when you need to say, are there like these life cycle hooks?
There really isn't a concept. It's a one-shot thing. It's at the startup of your application, all right? So there is no concept of it being removed, per se. I do have in my head of a rebase operation that you may do once the application is up and running. Let's say you've logged in, okay? Once you've logged in, that user's going to have different users are going to have different abilities and authorizations. So it may be that you want to do a rebase at that point to figure out, and reanalyze your features at certain points in time once the app is up and running. But the current system is strictly at the startup, at the very beginning of your application. Okay. All right. So this is really cool. Now for the first time, we've actually encapsulated the app-specific initialization within the features that It's really important because, especially when you start talking about disabling a feature, if you disable a feature, it shouldn't have to incur the overhead that it needs to initialize itself, which you don't in feature U. Okay? So it makes sense. I think it's a good design decision that you encapsulate that initialization within the feature that requires it.
And the only dependency is the app did start function, right? All the features start up in parallel, except for, I guess, F3.
It actually executes in that order. It will invoke all the features app will starts, and then it invokes all the app inits, and then it invokes all the app did starts. There's actually dependencies between there. I mean, I haven't gotten into the details of the signatures, but the app init, for example, it actually, for example, if you're Redux, if you have a state manager, it's going to pass you the application state and the dispatch function that you can dispatch actions for. So in order for that to operate, you know, there's dependencies. So it is really a requirement that those are executed in the appropriate order. And as we will see in just a moment, Launch App is not just dealing with features, but it's also dealing with the framework configuration, which is coming from a different set of objects. So in addition, we're not going to talk about this in a lot of detail. There are other lifecycle hooks for those plugin objects that are in the mix on this as well, for it all to work together.
And they operate outside of this, or kind of?
Well, it's a different set of objects. So the objects that are doing your framework configuration is more of a global process. It's not specific to any one feature, right? Your goal is to bring up the Redux state management framework. So it's a little different. It's similar in concept to these hooks, but it's different. So I mean, as an example, the plugins that does the framework configuration can also inject DOM into the root, your static root DOM. If you're familiar with Redux, it has to inject a provider so that you can access state throughout all of your components. So there's some things that are similar, but it's kind of a different process. All right, speaking of framework configuration, that's the next topic. This was the second subtenet of runtime configuration, if you remember. And this was a goal that I had from the very beginning, conception of this, because I knew it was going to be more difficult to configure your frameworks because it needs to pull in aspects across all your features in order to do its job, okay? So how can FeatureU support framework configuration when there's so many different frameworks out there and two projects are going to be using the same set of frameworks, right? Well, the obvious answer to that is that FeatureU is extendable. And that basically is the extension point to do framework configuration, or more precisely to do more of a global process, which framework is. It's not specific to any one feature, if that makes sense. So the extension point to FeatureU is the aspect object, capital A aspect, and I've got two of them shown here in green. And so you can see that that is also an input to FeatureU, to the launch app function. So now we can see that launch app is accepting both a set of features and it's accepting a set of aspects. So basically, the aspect is going to do some global process configuration, and typically it needs to gather information across all the features in order to do its job. So you can actually create your own aspect. As I mentioned before, there is a FeatureU create aspect function. But again, typically you're not hopefully going to need to do that because you'll be able to find the particular aspect that you need already prepackaged in NPM. This one happens to be a feature-redux package. And so in essence, it's an integration point between the Redux state manager and FeatureU. Okay? So instead of us doing all that bootstrap configuration to bring Redux up, it's going to be now found in this object here that's completely separate from our project. So in essence, the goal of Aspect is to gather all the information that it needs to do some kind of a configuration, a global configuration, and expose that in some way. So I don't know if you know anything about Redux. Are there any Redux users out here, state managers? But basically, the name of the aspect is reducer. I've color-coded that in green. That actually extends the feature object to allow reducer properties to be specified. And the aspect is going to validate that you've registered the correct data in here. In essence, it's expecting a function that is a reducer function. And so basically what it's going to do is it's going to gather up all the reducers across all the features that are maintaining state. It's going to combine that using the Redux combine reducer function and configure the overall complete application state. Configure Redux up and running, and you're pretty much done. Okay? No fuss, no muss. So we've actually reduced our code. We don't have to write that code. It's found in the plugin. So you see here that I also have a second aspect called logic, and this is a feature-redux logic module or package. Basically, this is a middleware extension point to Redux. It's a really popular Redux logic I'm talking about is a popular package that allows you to model your business logic. So it really makes your code modular and provides a separate unit testable business logic modules. If you're using Redux, I would highly recommend that you look at Redux Logic. It's a pretty popular package. So in essence, you see that the two aspects I have here pretty much kind of represents my application's runtime stack. I'm using Redux State Manager. I'm using this logic package to maintain my logic. Make sense? All right, let's look at this in some code. So basically, we looked briefly in our teaser at the startup process, the app.js. So launch app is basically being passed a set of features and a set of aspects. The two things that we just talked about. Features. Well, you can see here that it's actually importing the features from the features directory. So if we expand the features directory, not only does that contain our features that we have packaged there, but there's also an index.js file. And basically, all that's really doing is importing all the features across our publicly promoting them through a default export. So in essence, all those features are merely a flat array or sequential array of feature objects, okay? The same thing is true with the aspects. There's an aspects directory, and it has an index.js file. And ultimately, just like features, it's exporting a default array of aspect objects, okay? The main difference here is the aspects that it's promoting are basically being pulled from separate NPM packages, so they don't live in our code base itself. So if you did have to create a local aspect, the aspects directory would be a great place to actually store that, just like we do in our features. But in this particular case, I found all my aspects from separate NPM packages. So looking at the application, where did all of our complexity go? Well, we really need, first of all, the complexity for the framework configuration is completely removed from our code. It's completely found in those aspect objects in separate packages. In terms of our app-specific initialization, we need to look in the features to see the various callbacks that we just talked about. So let's do a search, and I'm going to search for the three different features, or callback functions. The first one, remember, was app will start. I'm going to search for that. And we just happen to have one in this particular case. So if I open that up, and if you look at the breadcrumb there, you can see we're in the common base UI feature. That's the common feature that's doing our UI fundamentals. And its app will start, could be doing a variety of different initialization, but in this particular case, all it's really doing is returning a main layout. Remember, this is the one that allows you to inject static content within the static root DOM. And so it does that by simply returning root element, in which case feature U is going to accumulate that. Basically, this is an accumulative process. You notice that it's passed the current root app element as a parameter. And so one of the heuristics that's important for you to do here is if you're going to inject something new, you must include the current one as well. So you can see, are you all familiar with JSX? This is JSX here. So in essence, it's including not only its main layout, but it's also including the current root app element. And that's important because if you didn't do that, you would drop something on the floor. It's strictly a sequential accumulative process. Make sense? Okay, the second callback, if you remember, was app init. Let's search for that. And there's several of those here. Let's just take a look at one of them. And again, if you look at the breadcrumb here at the top, you can see this is the GPS location service. So its app init is actually doing a get position. So this is actually a function that's doing an inquiry on the device to get its GPS location. And once it gets that location, it actually stores it in its application state by dispatching an action to do that. All right? Now you'll notice that this get current position is actually an asynchronous function. And so we've got the await there. We're actually using async await. So because this is the app init is adorned with the async, it means it's returning a promise, basically. So in essence, this is where feature U is going to block until that completes successfully. So if you notice here, I've got a diagnostic utility that's currently disabled, but it's adding a 3-second delay. So if I turn that on just to demonstrate it, let's pretend that this is going to take longer. I save that, I come back up here, you'll see that it's initializing GPS location for that 3 seconds. Okay, so feature U is actually blocking for that to complete. I'm going to turn that back off. Make sense? All right, the last one we talked about is app did start. And here we only have one. And this one again in the breadcrumb, this is the authorization feature. I talked about that before. App did start here is actually dispatching an action that will do an auto sign in. So in essence, the logic, if we followed that, it's going to look to see if you have saved credentials on the device, in which case it'll just automatically log you in. That's what I'm doing here. If you notice, every time I refresh, I didn't have to log in. It stored its credentials in the device. If it's not stored there, then it's going to actually present your user sign-in screens and ask you to authenticate. Make sense? All right, one of the things I didn't mention here on Launch App, one of the callback functions is register root app element. Basically, once feature U has accumulated your entire static DOM, it's actually calling back out into the application domain to do the registration. And we do that for a couple of reasons. Obviously, when we're doing this React DOM, we really don't know the static ID that you want to render that in. That's kind of application specific. But really more important to that, feature U doesn't know which of the React platforms that you're using. So this happens to be a web application. The registration process is React DOM.render. But it could easily be one of the other React platforms, such as React Native, if you're doing native development, or Expo, which is a layer on top of the React Native. And so conceptually, it has to do the same thing, but it's a different function call that does that, okay? So by that very simple heuristic of calling back out into the domain, application domain, you can see that feature U is actually compatible with any of the React frameworks out there, whether you're web or native. Make sense? So this is really cool. Now we've completely encapsulated all of our startup process, both app initialization within features by callbacks, as well as framework configuration using the extendable plugin. And key point here is that this is made possible because feature U is in control of starting your application up and running. That's an important point. Any questions? Let's take a slight excursion and talk about feature enablement. Basically, by default, all features are active, but you can disable them through the enabled feature directive, which we've already seen. So here's an example in code. We're in a sandbox feature, which is typically going to be a development feature. And we're only enabling that sandbox if we're in the development mode. Now, this is a more realistic example than the one we saw where we hard-coded it. Again, we want this to be a runtime expression so that it's going to actually change over time. So this too is made possible because feature use in control of your startup. I think you can imagine that the implementation of feature enablement is really, really, really simple in feature U. Launch app is given the list of your complete set of features that make up your application. The very first thing it does is it prunes that list to an active list and uses that going forward. So that's as simple as that implementation is. All right, let's look at this in some code. We do actually have a sandbox feature in Eatery Nod. I'm going to close out everything here. And the sandbox feature is under the common diagnostic. There it is, sandbox feature. Let's bring up its README file. Basically, you can see on the README file it says, if we enable this feature, we're going to inject some additional menu items in the left nav menu. So let's try that. Let's bring up its feature object. And you can see that it's enabled when the feature flags.sandbox is enabled. Okay, we'd already seen the feature flags. So let's go over to that particular definition. And we're in the feature flags, and here's the sandbox attribute. Let's just go ahead and enable that. And so now the system rebuilds, and our left nav menu actually has all the additional developer things that we've added that we can play with programmatically. And so, for example, I can see what a notification looks like. I can just drive it directly from that developer directive. And here, clicking this, you can see what a toast looks like. So you can play with different things programmatically. Okay, I'm going to turn that back off. All right, the second major thing that we talked about was feature collaboration. And remember, we broke that down into general cross-feature sharing, as well as UI composition that crosses feature boundaries. So let's take a look at how feature U accommodates those two sub-items. So here's the facets discussion, the spelling. Feature U uses something called facets to facilitate cross-feature communication, and that basically stands for feature assets. And this is how all cross-feature sharing is accomplished. You can think of a facet as basically the public API of a feature. And that API is truly open. You can register anything you want as a facet. Typically, it's going to be a function or a React component, but again, it can really be anything that you want in your design. As we will see, that facets supports both a push and a pull philosophy. Now, one of those is more important in order to obtain the dynamics that we need for this plug-and-play concept that we've been talking about. And here's the sidebar of your question. It's pronounced facet, but it's spelled facet as in feature asset. And I should mention that that facet term is used consistently both in the definition of those resources that we want to share, as well as the consumption of them, as we will see here in just a moment. Okay, so facets are introduced through the feature object through, guess what, the facets directive, okay? Now, as it turns out, there's actually 3 subdirectives that we support in facets. The first one is the easiest one to explain, and that's the define subdirective facet. So basically here, again, within everything, reason, this particular feature has decided that they want to publicly promote their A, B, and C resource, okay? And so I haven't shown the exact syntax here, but suffice to say through this define of A, B, and C, that that is now publicly available to other features, okay? So basically, Launch App, again, because it's in control of your system, can accumulate all those definitions from all the different features. And what it does is it promotes a facets object. This is the usage side of it. And basically, that's just an accumulation of all the facets across all features. So you can see here that we have A, B, and C defined from the F1 feature, and we have the X, Y, Z that's defined from the F2 feature. Facets object is, you can obtain access to it in a variety of different ways, and I'm not going to get into the details of that. Mostly it's like callback parameters that our feature you that's calling back out into your application code is going to hand you the facets. There are other cases where you can have functions that implicitly under the covers have access to the facet. Just suffice to say, as far as this slide is concerned, that it's very easy to access the facets object. So if you have access to it, you simply can the F2 feature. You really don't know. You actually supply wildcards there. So in that case, it's going to return an array of facets that match that particular pattern. And there's also a couple of implicit functions, use facets and with facets, that's actually interacting and accessing the facets object for user interface components. We'll talk about that in more detail. But the takeaway from this slide is that basically with the use of the facets, we can do all of our cross-feature communication without relying on the import that we talked about earlier. That's the anti-pattern. Make sense? There's our common theme. This is made possible because Launch App is in control of starting your application up and running. So let's take a look at this in some code. Yes?
You have both private and public feature with both private and public facets, and you make specifically decide the facets being public in the feature, and then the facets.
Yeah, no, there's no real concept of public and private for the facets. I was talking conceptually that because the feature is encapsulated, we want to consider everything that's there to be private implementation detail. We want it to be encapsulated. But it's really a convention because, I mean, certainly somebody can import some, well, if you export it. I mean, if you're not exporting anything from your feature, nobody else can import it, right? So it truly is private. But yeah, I'm talking more concept than a physical mechanism. Well, all facets have to be unique. So if you try to register a duplicate facet, feature U is going to complain and fail fast. So here we are in a feature A feature. I'm not very creative with my names here. Again, you know that I'm just using those as examples, right? These are going to be business or requirements-based features, so the name of the feature is going to make sense in the real world. So it's defining 3 facets here, 1 action and 2 selectors. So this is the full syntax here of the define. The right-hand side is basically just simply dereferencing it internally within your feature, however that is within your structure. The left-hand side is how you want to publicly promote it. So you can actually rename it if you so desire. You don't have to. And you can also use a federated namespace with the dot notation there. That's really up to you, however you want to do it. I kind of like to accumulate all my actions under one node and all my selectors under another node. So that's the definition of some facets. The usage of it, and again, this is presumably from another feature somewhere. If you have access to the facets object, you merely dereference it. Here I'm calling the isDeviceReady selector. that is actually defined in the feature A feature. Pretty simple, right? Now, I might note that this is using a push philosophy, the define is. So the feature A doesn't, basically all it's doing is really pushing these resources over the wall. And so they're available for your use if you want to use them. So that's what I mean by push. So let's talk about UI composition. How do components use these facets that are defined? So here we are in a common feature, and it's defining a company logo facet. Now this happens to be a React component. I don't know, again, if we don't have a lot of React developers here, but this is just a very simple functional component, an anonymous arrow function, which can be interpreted as a React component. And all it's really doing is instantiating an image tag, right? This could be as complex of a component that you want. Maybe you're going to pull that component from a separate module within that feature, right? This is just a simple toy example. But the point is we now have a company logo facet. Okay, so how do we access? There's really nothing new on this slide other than the fact that what we're registering here is a React component. It's the same thing we've seen previously. So how do we access this in another component? Well, the common way to do this until recently within React is higher order components. And that's basically where we wrap one component with another and we inject properties into that inner component. So feature use supplies a with facets function, and that's the yellow with facets there. And basically that is wrapping another component. You can see which component it's wrapping, the my component here. And it needs to inject properties in that component. It does that with this map facets to properties directive. So there it's saying I want the company logo facet to be a logo property. And so there it's injecting the logo property from that facet. And so since my component evidently knows that that logo is a React component, it simply is using JSX and instantiating that component within itself there. Does that make sense? There's actually an easier way to do that for the React developers out there. About this time last year, they introduced React hooks. And so feature use supports that as well. It has a use facets function, and that is a custom React hook. And so instead of wrapping that component, we can just have our functional component here, and using the hook, we say we want to use facets of company logo. That's returned as a variable, and again, we know that that's a component, so we simply use it in our JSX. So that's much simpler. It's basically doing the exact same thing with different technologies in React. Make sense? So we've now accessed that facet within our component. All right, UI composition can be a contract. And this is, I think, the most exciting part of feature U. It's really what is providing the dynamics that you've seen for the plug and play. So hopefully I haven't lulled you to sleep, but if I have, this is your wake-up call. So what do I mean by a contract? A contract is where one feature specifies a series of injection needs, and another feature or features will supply those needs for it. And so we do that with some additional subdirectives of facet. Remember I said there were 3 subdirectives. We talked about the define. The other 2 are here. The use directive actually specifies the injection needs. That's the usage contract. And the define use is very similar to define, but it's defining a resource under the usage contract. And so it's slightly different only in the fact that basically the usage contract can actually define validation constraints, application level constraints can be part of that usage contract. And so basically that's allowing feature U to do that validation for you, making sure that everything's wired up correctly as you expect it to be. Now also wildcards can be used in these usage contracts. And that is going to allow us to inject content autonomously, which is, I think, is really exciting. That's some of the things that you're seeing in the dynamics that we looked at in the previews. Now this is probably a little confusing here, but I think it's pretty straightforward once you see it in some example code. So let's take a look at that. So here we are in a main feature, and it's defining a usage contract. So the use subdirective of facets is being used. And basically it's saying, I plan on using resources that match mainpage.star.link. There's where the wildcard comes into play, okay? So anytime that a feature is defining a usage contract, it's typical to fill contract. And so here we are in the same feature in a different component, a different module. We're still in the main feature, but we're in some main page component, and it's saying, I want to use facets that match mainpage.star.link. That's the fulfillment of the contract. We said we're going to use it up here, and here we're actually using it. So again, because we have wildcards in play here, that's going to be an array of main links. And so at some point, we're going to iterate over that array and actually instantiate each individual main link appropriately. Make sense? Okay, that's the usage side. Let's look at the definition side. And typically, that's going to be from a separate feature. So here we are in a cart feature, color-coded in blue. And it's saying, I want to define under usage contract a mainpage.cart.link. And it's defining its on component to do that. Again, this is a simple one for our example. It could be as complex as you want. So because mainpage.cart.link matches that, it's actually going to be pulled into the main page. Make sense? All right, because wildcards are in use, multiple can join in on the fun. So here we are in yet another feature, a search feature, and it's doing something very similar. It's saying, I'm defining under usage contract the mainpage.search.link and defining its on component. All right, now this is actually really exciting. We've switched from a push philosophy to a pull philosophy, which allows us to have that dynamic. And especially with the wildcards, we're doing autonomous injection. The main page and the main feature and its main page component is orchestrating this work and instantiating these items, but it really doesn't know where they're coming from because they're being supplied through this usage contract mechanism. Does that make sense?
This is also how you feel like you use components at various places because you're always pulling from like this namespace, whether it be wildcard or like a link.
Yeah, I mean, other features can technically define the same usage contract. So there are other features that could say, I'm using the mainpage.star.link. Now, when that happens, feature U enforces that they are the same usage contract. We'll see here in just a moment where you can do validation constraints. So for example, if two features basically made the same usage contract and they had different validation constraints, feature U would complain about that. Make sense? All right, let's look at this in some example code. I think now some of the stuff that we saw that was kind of magic will maybe make more sense. So we were looking at how this sandbox feature, all we looked at, so remember when we enabled the sandbox feature, it automatically injected some stuff in the left nav menu. And all so far was the fact that we were enabling and disabling the feature. We didn't actually see how it was implemented. Well, if you look just lower here, you can see where it's defining under usage contract an app motif.leftnavitem.sandbox resource. And evidently that's a pretty involved component because if you remember, it injected like 15 different items on that left nav menu. So it's just an example that it can be a complex component as well. So I happen to know that this usage contract is coming from that UI feature. So if I load that up, here's the base UI feature in the common directory. Let's bring up its README file. And again, this is a fairly big feature, doing quite a bit. And it's actually using usage contracts throughout to do its work. But the thing that we're looking at here, interested in, is the app motif. And you can see that it's talking about the fact that it's managing the left nav menu, it's managing the title bar, it's actually managing the user menu. But all that's happening through usage contracts. So if we scroll down to the left nav menu, it's saying, well, we can items on the left nav menu, but you do that through the app motif.left nav item. Let me get my reading glasses. It's terrible to get old. Okay, here's the feature for the base UI. And there's a lot going on here, different definitions, defined uses. It's usage contracts. It's actually defining 3 usage contracts. And the one that we're interested in is appmotif.leftNavItem.star. And so this is the full definition of the usage. So if there isn't anything, feature U is going to fail fast. And it also says, it basically says it has to be a React component or something. Next thing I want to talk about AB feature swap. This is something that's very common in feature-based development. It could be that you want to, let's say, define a brand new version of a particular feature, but you're not exactly sure how it's going to be accepted, or there may be some issues with it. So the main set of users is going to be continuing to use the old feature, but a new set of beta users are going to use the new features. So depending on how they, their identification when they log in, you're going to instantiate one or the other. Or the common thing that we've talked about before, and then we'll be looking at this a little more, is the mock services, where you swap out in development mode a real service for a mock service. So actually, how we allow this to happen in feature U is we actually allow features to promote these services through these facets. And basically, feature U can do all the wiring for that. So again, we mentioned earlier that Eatery Nod has Eatery service for the Eateries feature. It has a discovery service for the discovery. It has an authorization service. So just as a general sidebar, so to speak, services is a really good idea in your architecture. In general, what a service is going to do is take a generalized solution and tailor it to a very specific app domain. So the end result of that is you've done all that translation within the service. You've greatly simplified your business logic because it's very focused on a specific app domain thing. So it doesn't have to worry about all the idiosyncrasies of Google Places API. It's all restricted into a specific domain itself. So that's just kind of a sidebar. But you'll see that there's a reoccurring pattern where there's like a 3-in-1 for each one of these service to kind of get a feel for what's happening here. So basically, services in this context are promoted through these usage contracts. And so you can see here that there is an auth service at the top, and it's the one that's actually defining the usage contract. And so what it's doing is it's saying there will be an auth service facet, and it's defining the validation constraints. In this particular case, it's saying it must conform to, from an object-oriented perspective, it must conform to the auth service API. But that's really an abstract API. It's not really defining the service. That's just a validation constraint. So there's actually 2 implementations of that service that are coming from different features. So we have a real service feature and a mock service feature. And so you see the auth service Firebase and the auth service mock. So they're both going to have to actually extend from the auth service API because that's a requirement that we set up in our validation constraint. But they're going to actually do different implementations. One's going to be sort of a, an in-memory mock service. The other one's going to be real services talking to whatever. But the key thing that makes this work is the enablement of these two services, the real one and the mock one, are mutually exclusive. Remember I said that all your facets have to be unique. You can't define the same facet twice, right? So if we wire this up incorrectly, it's going to attempt to, let's say, define two auth services, which it's not going to like. So they have to be mutually exclusive. Does that make sense? So with all that said, that basically feature U is doing a lot for you to ensure that everything is wired up correctly. So let's take a look at that in some code. I'm going to close out all of these. And so let's go into the authorization service. Here's our authorization feature. And the actual services are in sub-features. And here's the three services, the auth service, then the real one, and the mock one. So let's take a look at the usage contract first. So I'll bring up its feature. So it's defining a facet, and it basically says, this is the usage contract. It says there will be an auth service, and the reason that we know it will be is because it's actually required. And we've validated it saying it must be an object of type auth service API. And so this is the function that implements that validation there. So basically anything that defines that will match to this particular usage contract, and feature U will ensure that this validation is correct. So it's simply saying whatever you're trying to register has to be an instance of auth service API. So let's take a quick look at auth service API. So this is an object-oriented here. Auth service API has some methods that you would expect, a sign-in method, a sign-out method, et cetera, et cetera. But because this is an interface, well, it's really the closest thing I can get to an interface with pure JavaScript. I think if I was using TypeScript, I could actually define an interface. But here, I'm simply defining the methods with their documentation, and I'm throwing in an exception, saying, hey, you forgot to implement this. So the difference is you're going to see problems with this at runtime versus compile time or build time, so to speak. But in essence, this is all the consumer needs to know about this service. They don't need to know anything more than there is an auth service out there that will be there from somewhere, and it knows what the API is because it's well documented right here. Make sense? So let's look at the implementations then of this. So the first one is the real one, the Firebase auth service. Let's look at its feature. So this is the auth service Firebase, the real one. And it's saying, I want to define under usage contract an auth service variable. And I'm instantiating a new auth service. So if we look at that, we can see that it extends auth service API, which it must because that's part of our validation constraint. And then if you look at the implementation, you'll see that it's actually getting into actual Firebase code here. So it's the real implementation. So if we look at auth service mocks feature, it's a similar thing where it's for usage contract the auth service, the same auth service variable, but it's instantiating the auth service mock. So I think you can imagine if we looked at that, it's going to extend auth service API, and it's going to be our in-memory database that's doing whatever it wants to do, right? Now the key thing that makes this work is the enablement flags. The real service is enabled when feature flags use Wi-Fi is in effect, okay? The mock service is the opposite of that. There's the not there. When not using Wi-Fi, we're going to instantiate this, okay?
You will scream if that's not lined up right.
That's exactly right. Let's see. We're actually, yeah. It doesn't matter we're in the mock here. Let's get this wrong. Let's do it the same way. We'll enable it the same way. So I'll save that. And the system rebuilds feature U fails fast. Says the off-service mock error, facets aspect, defined use directive. Off-service is not unique, previously defined in off-service Firebase. So you can't define the same thing twice. And so you get the opposite of that if, let's say, we still had it wrong in the opposite way. So let's put them both to not. And I don't know what my hotkey is for save all. I'm actually an Emacs user, not a Visual Studio Code. So here is the same error in the opposite way. Well, so we didn't instantiate any of them in this case, right? Because we had it wrong. So it says it's a required use resource and off service wasn't found anywhere. All right? And then also the validation of the type is there as well. So we're instantiating an off service API derivation. Let's instantiate 1, 2, 3 just for fun. Off service. See here where feature U is doing all of the validation to make sure that everything is fired up correctly. But the enablement of feature objects is what's making this happen appropriately. Does that make sense? Any questions? Well, with that introduction, I think the context diagram for feature U will make a little more sense. You can see that, again, the launch app is in control. So it's the center of our diagram. It's accepting a set of features and a set of aspects. It's actually communicating to those through various lifecycle hooks to do the work of the startup process. It's calling back out into the application domain to register the root DOM element, which basically means it's compatible with any of the frameworks of, or the platforms of React. And then it's also promoting the facets object, which provides the cross-feature communication in an extendable way. Okay, before we wrap it up, I have one final word about feature-based development. We've talked about this briefly just before, and that is features should mirror requirements. And again, those can be end-user requirements or low-level system requirements. But this is really what makes your code intuitive and able to scale well, because as you add features, you're just kind of adding additional feature directories out there that will hopefully plug and play fairly well with your system. Now, the second point we haven't talked about, but I think it's kind of important to understand, and that is that features are really a different level of abstraction than other programming paradigms or constructs. And the reason for that is your code itself has to implement those other paradigms or constructs. So if you've decided you're going to use functional programming, it's up to your code to implement that, regardless of if you're using features or not, right? So if you think about it, features are really more about a logical packaging with the ultimate goal that your system can plug and play with those features. So what does this mean in terms of feature U? I've often fielded the question, how does feature U impact my, and then fill in the blank? It could be that you're modeling your business logic with your components. It could be that you're using the XYZ framework, et cetera, et cetera, et cetera. Well, I think you can probably imagine the point I'm trying to get to here is that feature U does not impact you in any way here. So what I'm really trying to say here is that feature U is non-intrusive. You use the same constructs and the same styles. You use the same frameworks in the same way. The only difference is your scope is smaller. If you're a miniature application, your scope is within the boundary of that feature. So quite the contrary of feature U being intrusive, the bylaw U is it frees you up on the business end of your features. So lest you think I'm becoming a marketeer, I went ahead and added the part there. Speaking of marketeering, this is the marketing diagram of Feature U, and it wouldn't be complete without Feature U-Man. Basically, this is the same thing as the context diagram that we looked at earlier. It's just pushed up a little higher with some additional graphics added to it. All right, your assignment, should you choose to accept it, is there's a section in the document toward the end called Why Feature U. And there I list out a number of benefits of using Feature U. And so within that, I make the case for that, and I also provide context links back into the user guide to give you more context for that. All right, that's about all I have. If you guys have more questions or want to hang out afterwards, I'd be happy to field that. You can hit me up at my email there, my Twitter account. Direct messages are open as well.
You show resources for, I guess, feature-driven development. Have you come across any books related to this, or?
Some of the articles, I've not seen books. I've seen kind of academic papers on it, and there's some of the articles will list several resources in terms of articles on Medium or whatever that you can read about.
Do you find that developing this way and thinking this way about the structure of your code, does it change the way that you write proposals? Like, cause it feels like if you're doing feature-based development, there's a lot of it that hinges on being very clear upfront with the feature list and the proposals going to the client and stuff like that. I'm just wondering, like, is it affected one way or another? Like unclear proposals affect the way we build, or do like hyper focus proposals affect it, or is it
I guess trying to figure out the underlying question there. It's kind of like, are you saying that you're thinking that it has to be more defined up front per se, or?
so context of the question is that it's very good at writing proposals and bringing and then I worked at companies where it's like, hey, developer didn't look at it at all, and developer and makes me wonder, like I look at this and I'm like, well, there's an advantage to it because if it is unclearly defined and if for some reason you can't iron that out before you have to start building, since everything's encapsulated, it's like if this feature went bad, we just create a new one and swap it out. But like or trying to figure out how to say it, like it makes me wonder how much affect what people are wanting you to build and the quality of the features that come out. Like if it's like I don't know.
Yeah, I'm not exactly question. Into the world of design, there's all kinds of variables that are involved. Sound formulation of the heuristics that you want in your proposals that the feature-based development. I mean, technically, the feature-based development should match your business requirements, and so if that's a direct correlation to the proposal, then they should match fairly well. In practice, I mean, there's a lot of design your features, and so it's like anything else. It's defined what it should be. Actually look up feature. It's actually, I think the acronym is FDD, feature feature-driven development. And I think a lot of that is actually focused on Agile. and your Agile process is kind of driven based on features as well. I haven't seen a lot of talk about that actually going into your code, but maybe it does. I haven't read that. But I mean, as a general rule, the features should match your business document. But I mean, you're going to get into, I mentioned, system level features. I'm not sure I answered your question.
But like, I feel like there's an advantage in this, as far as flexibility. Just trying to think of how to word this. I don't know.
Yeah, I mean, in general, I mean, especially when you get in the enterprise level, the amount of code that you're talking about there, again, the whole concept of organizing itself. So that's change-based orientation, I guess.
I mean, this does though seem like you're really starting to bring the tech side and business side together, just explicitly, feature-driven development. I don't know, that's kind of what you're getting at, just where you're really pushing the code, the development code up one step closer to the actual requirements and the features to where, a business user, they won't know how to code, maybe wouldn't understand most of what you talked about, but there's
Somebody, like, you could walk by feature by feature and be like, here's your hit there, here's your
right,
exactly.
yeah.
Yeah, I mentioned earlier the topic of micro front ends. I've seen several articles on that in the last year. And the whole idea there is like, you can even be, it goes a lot further than this from what I've read on it. I'm not an expert on it, but you could have, your micro front ends could be using completely different architectures. One could be using React and one could be using Svelte, and completely different teams. But somehow those features have to interact together. So I'm not exactly sure. I mean, I've got some strong proponents of this that I've met through open source. One guy is head of one of the major Disney development devices, and he was really excited about this. He's saying, we've got so many different systems that have to interact together. And so I think he's struggling at this point with their existing legacy systems, how they tap into this on an incremental basis. But certainly, it's like anything else, if you put the proper forethought in on the front end design, and I think this is something that would be very foundational within a design. If you were using something like this, I think it would be able to be much more agile and to react to various requirement changes that come down the road. Certainly, the alternative, to type-based, really type-based is not something that should ever be used in a large-scale enterprise level. It just becomes spaghetti code after a while, right? It's funny though, because within the feature boundary itself, I struggled with this for a while because it's like, I don't know if you noticed or not, but some of my features, all the modules within the features aren't just flat lists there. Some of them have directory structures like components, right? And at first I was saying, oh, no, I don't want to do that, it's type-based. I don't think necessarily a type-based structure is bad within the context of a boundary that makes sense, right, that is manageable. But certainly when you have one directory of components or 1,000 components that has 500 features in it, it becomes unmanageable pretty quickly.
This feels like it's code base as well. Like it's one thing where you're going into
Exactly. Your code base is much more intuitive knowing what your requirements is, you can say, I think it needs to be in this area right here, and there it is. And it's, you know, the problem space is much smaller into these miniature applications. So you don't stuff, right? All right. Well, I appreciate your time.
Thank you, Kevin.
Technical questions outside of the software. What's the presentation tool that you use?
This,
Yeah,
you don't know? It's PowerPoint.
I'm not seeing that in simulated flash.
Oh, that's my digital pointer. That's not PowerPoint.
Yeah, so that's what's interesting.
Yeah, this is an upscale pointer. Most of them use LED, and they have the ability to advance forward and backward. But this one's digital, so you had to drop just a little over $100 for that.